Okay, well, here we go. We're starting off chapter 16, and in chapter 16, what we're going to do is we're going to look at some basic data structures. In fact, data structures that we've already been working with, primarily the linked list and the array list. But what we're going to do is we're going to open up the hood, and we're going to look at how those things get implemented so that you have a better understanding of why they work the way they do, especially in terms of the speed that it takes to do different kinds of operations. And maybe why the interface that's presented to you as someone that's using a class, like a linked list or an array list, is the way it is. In order to do that, we're going to look a little bit at the plumbing underneath these data structures. The way that I'm doing slides is a little bit funny, so I have to give the computer a voice command in order for it to understand for me to advance the slide. So I apologize for that, but the clicker doesn't work in this software. So today we're going to start on chapter 16, basic data structures. Move right. So our chapter goals for this chapter are fourfold. We want to understand the implementation of linked lists and array lists. Now remember, when I say implementation, I'm talking about as a systems programmer, someone that's creating these kinds of data structures, the linked list and the array list, so that other people can use them, the API programmers. So we're creating an abstraction. We also want to be able to analyze the efficiency of these fundamental operations that are provided by lists and arrays. We're going to look at order big O notation, maybe the first time that you've seen it. Maybe you've seen it in another class you've taken before, but it comes in handy in order to analyze why things are efficient or inefficient. We're also going to look at implementation of stack and queue data types as well. We'll look at how to implement a hash table and try to understand the efficiency of its operations as well. Move right. So now, let's kick off by implementing the implementation of a linked list. Now, the first thing to understand about the implementation of a linked list is that there's actually 3 different classes that you have to think about in order to implement the linked list. The first class is the linked list itself. That's the class that you're working with as an API programmer that's provided by the systems programmer. In addition to the linked list class, you also have a node class. The node class is a class that's used by the linked list in order to implement the list behavior. The third class is the class of the data that the user wants to store in a linked list. Remember, a list is a collection of items whose order is maintained and which can have duplicate elements in it as well. So we're going to implement what's called a simplified singly linked lists. There are other kinds of linked lists, but that's one we're going to do. It's going to store the data that the user provides in a sequence of nodes, in particular, not just generic nodes, but a node class. And the node object is going to store the element and the reference to the next node as well, creating a chain through memory. So the first thing that we have to introduce is the idea of a private inner class and public instance variables. All right. So in this little snippet of code, you see that we're defining the bigger data structure of the linked list. And we haven't seen this before, but inside that data structure, the linked list class, we're going to define another kind of class called a node class. By putting it inside the outer class of linked list, only the linked list is allowed to access it, much like a private instance variable. And so in this snippet of code, you see that we have the linked list, and internally we have a second class, the node class. The node class contains 2 instance variables. Data, that's the data that the user wants to store. You can see that it is of type object, which is the parent of all classes. So we can store any object that we want, as long as it's an object, using that data reference. And then internally, we have a separate instance variable called next, which also points to a node. That's an interesting construction because what we have is the node class, and within it, we have a reference to another node class. So it's almost recursive in the way that it's defined. Move right. All right, now the node class itself is going to be the pieces that form the chain in our linked list. And our outer class, the linked list, is going to have a private instance variable called first. And first is going to be a reference to that first node in the chain of objects that we're keeping track of for the user. So first has to be a reference to a node class. In our constructor, what you can see is that we are going to initialize our instance variable first to be equal to null, so that when a user creates a linked list, it begins with no data inside it. Because we have an instance variable called first, we can also create a getter called getFirst. And we're just going to do a little bit of resilience, a little bit of error checking in that, so that if a user of our linked list calls the getFirst method, meaning the user wants to get the first element that's in the linked list, in that list of elements, and if there is no data there, then we know that first will be equal to null. And so we're going to check that condition, and if we encounter that condition, we're going to throw an exception. We're going to throw this no such element exception, and the program is going to break. If there is data there, then notice what we're going to return. We're not going to return first itself. We're not going to return the reference to the node class. Instead, we're going to return the data that's stored in the node class. So when a user calls getFirst, they never see the node class. GetFirst is a method that's part of linked list, and what gets returned is the data that's in the node. But the user never sees that. They just see their data coming back that they put into the linked list previously. Move right. So that's fine. That enables us to have a constructor for our linked list. But how do we add elements to our linked list? Well, let's say that we would like to add something to the beginning of our linked list. That'll be the first method that we implement. So when a user wants to put something at the beginning of our linked list, we'll ask them to call the addFirst method, and we'll have them pass the parameter, which is the data that they want to store in that linked list. Okay. In order to store data, what we need to do then is we need to create a link in the chain. We're going to create a node object by calling the constructor on node. Now we can do this because this is a method that exists within the linked list class, and so we have access to the node class because we're within the linked list class. So node, even though it's a private inner class, is accessible to us. So the first step is we'll create that object. Then we're going to store the data that the user passed in, the element variable, into our node. And then what we're going to do is we're going to link in that object that we've just created to the beginning of our chain. And the way that we're going to do that is we're going to say this new link that we have, then the next element in that link is going to point to whatever the linked list previously had as a first element. And we'll say that the linked list's first element now points to this new node. Let me show you what that looks like visually. Move right. Here's an example of what we might have in a generic situation with a linked list. Now, when you do these kinds of coding, you need to think about all the different conditions that you can have. An empty linked list, a linked list with several elements in it. But let's imagine we have a linked list already with some elements in it. And I want you to notice in this diagram that we've got different class names at the top of our objects. They're not all the same class type. The first one we've got is a linked list. And you can see that that linked list has a first element pointing to the first element in the chain. That first node class has a next element, which has an arrow going off to the right, and that would point to another node, which points to another node, which points to another node. Each one of those nodes holding the data that the user wants to store in that list. When we now want to add something to our, add something to the beginning of this linked list, what we do is we create that new node, that's the one on the bottom. We have a reference to it locally called new node, and then we do two steps. The first thing that we do is we link our new node's next element to what the linked list previously pointed to as first. And so you can see we're splicing into this chain the new node that we just created. After we've added that next element to point to what was previously the first node in our linked list, then we changed the linked list's first element to point to the new node that we just created. And in this way, we've inserted this data that the user asked to be put at the beginning of the linked list into our linked list. Move right. Move right. Now let's say we want to do the opposite. Let's say we would like to remove the first element. So the assumption here in the design of this method is that when a user asks to remove the first element of their linked list, they want the data that's stored in it, and they want the rest of the linked list to work right. They want it to be as if the first element is now what was the second element. So the data from the first node, we're going to pull it off the chain, we're going to clean up our chain, and then we're going to return that data. What does it mean to clean up the chain? Well, it means to take whatever the first node was pointing to and now make that the first node. So if we look at this method called remove first, a method that a user of our linked list class is expected to call, we're first going to just check that error condition. We're going to make sure that there's something in our linked list. If there's nothing in our linked list and someone calls remove first, then first will be equal to null and we'll throw an exception. You can't remove the first element if there is no first element. But if there is a first element, we're going to store the data that it contains by saying first.data and storing that in a local variable called element. We're going to keep that there so that we can patch up the rest of the chain before returning that data back to the user. How do we patch up the chain? Well, the linked list first reference now needs to point to what the first.next used to point to. So we're going to step through that chain, we're going to bypass that first element, and then once we've bypassed that element, we're just going to return the data that was stored in our first node. Move right. Here's an example of what that looks like. At the top, you can see that we have a chain of nodes, starting with our linked list class the user has access to, but then being carried out by a sequence of node objects that the user doesn't know about. All the user knows about is the data that's stored in the data variable for each one of those node classes. We would like to remove the first element. So what we're going to do is we're going to take that first element that linked list points to, we're going to do first.data and grab the data that's there, and then we're going to say first equals first.next, bypassing that first element so that the next time we go and work with linked list, our first element won't point to what was first, it'll point to what was second. And in that way, we've successfully removed the first element. What happens to that first element? Well, Java has a garbage collector that goes around and finds objects in memory that have no one pointing to it and removes them. Okay, that's kind of where I want to stop with this first concept. The idea of a linked list that contains an inner node class and has a chain of nodes that follow after it. Thank you.